All right, let's talk about a huge topic, physics. But hey, forget the dusty chalkboards and the scary equations for a second. We're going to explore physics for what it really is, the ultimate adventure to figure out the basic rules of, well, everything, from the tiniest little particle to the entire universe.
Okay, so here's our game plan for this journey. First, we're going to dig into what makes physics so, fundamental. Then, we'll see how our whole view of reality got flipped on its head. After that, we'll explore how physics literally builds the world around us, unpack the unique way physicists think, and finally, check out the surprising, and I mean really surprising, range of careers it can lead to.
So, first up, why do people always call physics the fundamental science? Well, it's because at its core, it's the bedrock. Think of it like this. Other sciences, like chemistry or biology, are built right on top of the principles that physics discovers. So the bottom line is this. Physics is on a mission to find the simplest, most universal laws that govern reality. It's asking the biggest why and how questions out there. It's kind of like trying to find the universe's instruction manual. And this quote just nails it, doesn't it? These fundamental laws aren't just for textbooks. They're the real-world foundation for pretty much our entire modern life. Every single piece of tech we use, from the phone in your hand to a satellite in orbit, exists because we figured out some of these principles. Next up, let's look at how our understanding of those rules went through a total revolution. It completely split physics into two major eras, giving us two wildly different ways of looking at the world. For centuries, it was Newton's world. His classical physics described everything like a giant, predictable clock. It just worked. But then, in the early 20th century, bam! You get this one-two punch from Max Planck with his weird idea of energy packets, and of course, Albert Einstein. They completely shattered that old clockwork picture and kicked off the truly bizarre and amazing age of modern physics. And what's so cool here is how you can see these two separate worlds. Classical physics is perfect for our everyday scale. Throwing a baseball, building a car. It makes sense. But modern physics? That's the rulebook for the extremes. It's for the quantum world of atoms and the relativistic universe of speeding galaxies and black holes. So we have these grand, sometimes confusing theories. But how does all this quantum weirdness or classical mechanics actually show up in our daily lives? Let's connect the dots from a wild idea on a blackboard to the world we live in. There's this really clear pipeline, you see. A physicist has a breakthrough, often just out of pure curiosity. Then an engineer takes that new knowledge and figures out how to use it. And before you know it, that abstract idea becomes the very computer or phone you're looking at right now. And this connection is absolutely everywhere. Think about it. Thermodynamics literally powered the Industrial Revolution. Our understanding of nuclear physics gave us not just a new source of energy, but also incredible medical tools like MRI scanners that can see inside the human body. Okay, but here's something really cool. Beyond just building stuff, studying physics fundamentally changes how you think. It's not just about memorizing facts. It's about learning how to tackle problems. It gives you a pretty unique set of mental tools. One of the most famous of these tools is the art of the guesstimate. And yeah, it's exactly what it sounds like, a mix of guessing and estimating. It's a kind of superpower for dealing with questions that at first just seem way too big or complicated to even begin to answer. The legendary physicist Enrico Fermi was a master at this. He loved to ask questions just like this one. He didn't actually care about the exact answer. The whole point was to teach his students how to break a giant, scary problem down into smaller, bite-sized pieces that they could actually make a reasonable guess about. This leads to another core idea in the physicist's mindset, and it has the best name ever, maximal sleaze. This quote captures it perfectly. It's the art of stripping away all the messy, unnecessary details to find the simplest possible model that still works. And let me tell you, that skill is pure gold in any job. So, what's in this mental toolkit? It's about being okay when things aren't perfectly clear. It's understanding that a good enough answer right now is often way more useful than a perfect answer that takes forever. And maybe the most important one, it's about being comfortable with not knowing. Seriously, in physics, saying I don't know isn't a failure. It's the launch pad for every single discovery. So you've got this deep knowledge and this powerful way of thinking. What can you actually do with a physics degree? The answer is probably a lot bigger than you think. It's almost anything. Sure, working in a university lab is the classic route, but it's not even close to the whole story. Just look at this breakdown. The problem-solving skills you learn in physics are hugely in demand in engineering, in software development, and, get this, even in high finance.
And these aren't just niche jobs. They're often incredibly rewarding. You've got quants on Wall Street using physics-style models to understand the market. You have data scientists finding critical patterns in enormous sets of data. You even have patent examiners using their deep tech knowledge to shape the future of invention.
At the end of the day, physics is so much more than a subject. It's a creative, powerful, and deeply human way to understand our place in the cosmos. It's a lens for looking at the world that gives you both clarity and a sense of wonder. Which really just leaves one last question for you to think about. What will you discover?